Alright, ladies and gentlemen, so you've never had me do this for you before, but I needed to make a little video because I have to give you two terms and I'm not going to be there the rest of the week. So we've talked about different units, we've talked about work, we've talked about power. There's two ideas that we need to be aware of when we work with simple machines. The first one of those is called mechanical advantage. And so it's signified with an MA. And mechanical advantage is basically telling you how much easier the machine is making the work. Okay, so if you get a mechanical advantage number of, say, 5, it means the work is 5 times easier to do, which means I can push in with 100 pounds of force and I can get 500 pounds of force out the other end. Now, when we talk about mechanical advantage, it's important for you to know it's a relationship or a ratio, and it has no units. It's just a number. And so the way we're going to calculate that number is right down here with this equation. MA equals the output force divided by the input force. So how much force you get out of the machine divided by how much force you put into the machine. That's your mechanical advantage equation. And when you do that number, it's going to tell you how much easier the work is. Okay? So if you have a mechanical advantage that's equal to 1 when you do that work, it means the output and input forces equal each other, which means it's not making it the force any less or making it any easier from that perspective. But you can still apply a change of direction to the system, which can make it easier, but it won't show up in the mechanical advantage number. So the mechanical advantage number is just if the forces are making it easier. If you have a mechanical advantage that's less than 1 when you do that equation, it means you actually have to push with way more effort to get something that's really light to be lifted. And so that mechanical advantage of less than 1 is making the distance relationship easier to deal with than the force. And so an increase in the distance of an object moved usually results in a mechanical advantage of greater than 1, because you're going to apply less force if you have greater distance. Okay? And so the other term you need to be aware of is efficiency. Efficiency has to talk about how much of the energy or work I put into a system do I get out. Ideally, it's 100%. 100% of what you put in, you get out. But when we're talking about machines, we're talking about friction. Anytime two things rub together, some of the energy is used up in that rubbing process. And so you never get all the energy out that you put in. Some of it's wasted in that form. And so all of these machines have friction involved with them, which means they lose energy, and the total amount of energy is always less than 100%. And so efficiency is how much of that work do you get out that you're putting in. So the equation for that's right down here at the bottom, and it's pretty straightforward as well. If you take the work that you get out of the system, the force and distance that comes out of the system, and you divide that by the work input, or the force and distance you put into the system, that will give you your efficiency number. Now that gives you a fraction. You multiply that by 100 and that becomes a percentage. So if it turns out your machine is 80% efficient, it means 80% of the energy you put in, you get out. An example is a car. A car burns energy in the form of gasoline. It only gets out about 15% of the energy it puts in. It's not a very efficient machine at all. And so where's all that energy goes? It doesn't go into turning the tires. It goes into heat loss and sound and noise, light, all of those other forms of energy that can be out there. So we have mechanical advantage. It's a number that tells you how much easier the work is. And we have efficiency, which tells you how much of the energy I put into the system I get out. All right? Have a good week. I'll see you guys Friday.